We're going to learn how to solve differential equations that we'll be seeing in Chapter 8, and they are second order, linear, constant coefficient, homogeneous differential equations. So in math terms, we can write it as ay double prime plus by prime plus cy equal to 0. And there's a standard way to do that. Now, if you read this slide, I'm not actually a fan of it. Instead of calling the coefficients a, b, and c, they first divide so that they get a 1 in front, and then the middle one, instead of calling it b or something, they're going to call it 2 alpha, and then instead of calling this one c, they're going to call it omega naught squared. You may or may not have ever seen that before, but it allows you to write the quadratic formula like this instead of the negative b plus or minus that you're used to. It doesn't really matter, and I'm not a huge fan of it, but we can do this. Regardless, when you're solving this differential equation, you need to convert it to what's called the characteristic equation. And what the characteristic equation is going to be as squared plus bs plus c. And I'll use the normal quadratic formula for this, negative b plus or minus the square root b squared minus 4ac all over 2a. And so the idea is you're going to solve. And there's three possible scenarios that you might have. The first is that you're going to get two different values of s. And we're going to call those S1 and S2. Then once you have that, you know the answer is going to be a1 e to the s1t plus a2 e to the s2t, and you've already written down the solution of the problem. So you have your s1, your s2, and you need to find your a1 and a2. And it turns out, Chapter 8 problems, the really hard part is finding the a1 and a2, not finding these s's. These s's will be almost immediate on the problem. So just understand the a's are going to be the hard part. The other scenario is if you have a repeated root. So that means you have the same number s, say, twice, repeated root here. Then in that scenario, it's going to be a1 e to the st plus a2 t e to the st. So again, these are the results from differential equations. You can take 252 if you want to try to see where these things come from, but this is how it is. And the third, the more interesting of them, is when you have complex conjugate roots. And when you have complex conjugate roots, I'm going to call these, let's see, I don't want to use alpha. How about I do beta plus or minus I gamma here. Forgive the Greek letters, but the idea is beta is the real part and gamma is the part with the I. And whenever you have this, then your solution is a1 e to the beta t cosine gamma t plus a2 e to the beta t sine gamma t. And so really, whenever you're solving a Chapter 8 problem, you have to know these three different varieties and what the solution is going to look like. And that's supposed to be the easy part of Chapter 8 problems. Then finding the A1 and A2 is going to take you the most part of the time. Okay, so if you have never seen this before, make sure you remember these three possible solutions.